Hello everyone, we're looking at dividing radicals, and today we're going to look at multiplying by the conjugate. Conjugates are a binomial whose sign separating the terms in that binomial is the opposite. So here's an example. I have 1 plus the square root of 3. The conjugate of that is 1 minus the square root of 3. Here I have 4 plus the square root of 5. The conjugate is 4 minus the square root of 5. Okay, pause the video and go ahead and answer what the remaining given binomials conjugates are. Alright, this one is 4 plus the square root of 5. And if you'll notice, a binomial whose sign separating the terms, these are the terms, okay, these are the terms, and it's the sign separating them is the opposite. So this was a plus sign, so what does it become? Negative sign. This was a plus sign, so what does it become? Negative sign. Or plus, minus, plus, minus. This was a minus sign, so it becomes a plus sign. For this one here, it's still a negative 3. There's nothing to do with the sign that's on the first term. It's just the sign separating the two terms. So plus square root of 3. This negative 2 minus the square root of 6. And this is important to be able to determine the conjugate. The sign in the middle is what's important. You change them. Because what happens, let's look at multiplying conjugates for number 1. These are conjugates. See, my terms are the same except for the sign separating the two terms. These are conjugates. What happens whenever I multiply those together, and we saw this in the video where we were multiplying radical expressions, it removes the radicals if it's in this form. An integer plus a radical, an integer minus a radical. It cancels out that middle term. Remember that? We saw those on a couple examples. We canceled out those middle terms and we were just left with an integer. So 1 plus the square root of 3 times 1 minus the square root of 3 will give me 1 minus the square root of 3 plus the square root of 3 plus, well, the square root of 3 times the square root of 3, negative square root of 3, ends up giving me a negative 3. So 1 minus 3 is a negative 2. So if you'd like, pause the video. And let's see if we end up with the same answers. Okay, 4 times 4 is 16. 4 times the square root of 5 is 4 square roots of 5. Negative square root of 5 times 4 is a negative 4 square root of 5. And a negative square root of 5 times the square root of 5 is a negative 5. My middle terms cancel. See, this is a positive and this is a negative. These are opposite of one another. They cancel out. I'm left with 16 minus 5, which gives me 11. Negative 2 times a negative 2 is 4. A negative 2 times a negative square root of 6 is a positive 2 square roots of 6. Square root of 6 times a negative 2 gives me a negative 2 times the square root of 6. And the square root of 6 times a negative square root of 6 gives me a negative 6. Again, these two terms are opposite of each other. One's positive, one's negative. They cancel out. 4 minus 6 is a negative 2. And that is multiplying by conjugates. So let's look at that with what we're going to do. Now I hope that you've noticed that in our problems dealing with division, it really actually turned into multiplication. and most people prefer multiplication over division, but division is simply a form of multiplication. It's how your brain sees it. So here we have an example. Divide and simplify. So this is my problem. 3 over the square root of 2 plus 1. And how we divide is by multiplying by the conjugate. We're going to multiply by this conjugate, and that will remove the radical symbols from that denominator. So 3 times the square root of 2 is 3 square roots of 2. 3 times the negative 1 is a negative 3. And square root of 2 times the square root of 2 is 2. Square root of 2 times the negative 1, negative square roots of 2. 1 times square root of 2 is 2. And 1 times the negative 1 is a negative 1. These cancel. They're opposites of each other. I'm left with 2 minus 1, which is 1. Therefore, my final answer is 3 radical 2 minus 3. Another example, I'm going to multiply through by the conjugate. The conjugate of the square root of 3 minus the square root of 2 is the square root of 3 plus the square root of 2. So I'm going to multiply both denominator and numerator by that. This is my product for each one. Notice here, these will cancel. 3 minus 2 is 1. Now, in the two examples that you've been given, the numerator completely cancels out. It does not have to. But what you will notice is that there are no radicals left in the denominator. I cannot do anything with this. I have the same root indices, right? But my radicands are all different, and I cannot simplify those to where I can combine them together. So this, my numerator, is my final answer. Alright, so let's look at some examples. If you would like, pause the video, work them, and let's see if we end up with the same answers. Okay, I'm going to multiply through by the conjugate. The conjugate of this is 2 plus the square root of 5. So 2 plus the square root of 5, 2 plus the square root of 5. 4 times 2 is 8, and 4 times the square root of 5 is 4 square roots of 5. 2 times 2 is 4. 2 times the square root of 5 is 2 square roots of 5. And a negative 5 times 2 is a negative 2 square roots of 5. They cancel. So now I'm left with the negative square root of 5 times square root of 5, which gives me a negative 5. My final answer is a negative, and it can be written like this. Just distribute that negative sign through. Because what does this become? 4 minus 5 becomes a negative 1. Multiply through by the conjugate. 3 minus the square root of x, 3 minus the square root of x. 9 times 3 is 27. 9 times a negative square root of x is a negative 9x. Over 3 times 3 is 9. 3 times a negative, and I'll write that out for this one, and then x times 3, see, those are going to cancel, and that turns into a negative x. Those cancel. So 27 minus 9 radical x over 9 minus x. And I've rationalized my denominator and simplified my problem. My conjugate, square root of 6 plus the square root of 5. And I'm going to multiply that through to the denominator and the numerator. What I do to one, I do to the other. Square root of 5 times the square root of 6, square root of 30. Square root of 5 times the square root of 5 is 5. 1 times the square root of 6 is the square root of 6, and 1 times the square root of 5 is the square root of 5. Square root of 6 times square root of 6 is 6. Square root of 6 times the square root of 5 is plus the square root of 30. A negative square root of 5 times the square root of 6 is a negative square root of 30. And the square root of 5 times square root of 5 is a negative 5. Those cancel. 6 minus 5 is 1. And there's nothing more that I can turn around and do with the square root of 30. I don't have a perfect square for 9, 16. And there's no rhyme or reason to how you write them out. Usually you put the constant first and then your radicals after. And that is your answer. And that is dividing radical expressions using a conjugate to rationalize your denominator. Okay guys, critically think and structure your homework, and good luck on your remaining homework problems.